Yeah, thanks. Yeah, I'm from, well, I live in Auckland, but I've got a strong Christchurch accent, so I'll try to speak slowly and clearly. So, yeah, with dodgy Kiwi vowels. So, yeah, I've got a BE Honours in Electrical and Electronic Engineering, and I started programming in LabVIEW in 6i 20 odd years ago. My career's mainly been in the product test, engineering, and test stand sort of fields. And I work for CPE Systems. Actually, I think it's actually now 4 years. I think a bit more about it. Though I left them a year ago. And I've also got the C certificate. Huh? Oh, it's the CLD. I can never remember the acronyms. Okay, they're 4-hour exam, which I do actually recommend you do because practicing the practice tests and trying to program something within a 4-hour time frame is a good way to actually realise if you're programming at the pace that's required. So you do look at the example tests and go and work towards that one. But yeah, that should be CLD. I'll fix that. Here's the last minute edition. So non-acknowledgements and credit for this presentation. Darren Nettinger, the quick drop guy. I've sort of mashed together some of his ideas from some of his presentations, some of my own stuff, and I read how to become the world's third best LabVIEW presenter, so hopefully I don't let you down. He's also got LabVIEW nuggets, which are quite a good resource on the forums, so I actually encourage you to go and look on the forums and spend some time around there, because there's lots of good stuff you can sort of pick up. For our giants, our female slide, I picked Beatrice Tinsley. She's also alumni of Canterbury University. So she was a British-born New Zealand astronomer and cosmologist and the first female professor of astronomy at Yale. So she made fundamental contributions to how galaxies evolve, grow and die. But she also sort of faced things like she was married to another academic, and for some reason they couldn't both work at the same university. Seems weird to me, but anyway. So the agenda of this presentation is a few tips on how to program in LabVIEW faster. I've got some philosophical ones first, then some more practical examples, and then sort of the future of faster programming. This isn't about how to program your code so it runs faster. There's a session on that later this afternoon. So first is, don't lose the code you've written. Backup, source code control, and if you reuse code, you know, check your VI parser as expected in a project, because if you come back later and it's all cross-linked, it is a bit annoying to uncross-link it. And I say this because, yes, just last week my test system blew up my laptop when I power cycled it, and yes, there was a surge of power through a USB CAN adapter into my laptop and the smoke came out. It wasn't NI hardware, so the NI guys can relax. But yes, so it happens to the best of us. And I was under the gun last week to try and get a test system out the door because I've got this week off, so yeah. The other thing is, love the code that you wrote. I've been there looking at code that I wrote a few years ago and think, what was I thinking? And that code would be so much better using the latest LabVIEW feature, like such as sets. So if it worked in the past and it's been debugged, just reuse it. I know that's hard. I've been there and we should tweak that a bit, or you know, that could be a bit more efficient, or. But if it works, good enough is quicker, yeah? And I've got a comment in here about comments. I find that subdiagram labels visible by default meant that I got enough comments in my code without being sort of zero comments self-documenting code and too many comments, and then you've got to maintain the comments and you end up with misleading comments because your code changed and your comment didn't. So, an appropriate amount of comments means that when you do come back to your code, you can look at it and pick it up quicker and remember what you were thinking a few years ago, because you're all so much smarter now. The other thing is, don't forget project planning. Spend some time up front to plan the best way forward with the project. I'm a bit of a fan of rapid learning cycles, if you haven't heard of that. The aim is to close knowledge gaps quickly and to reduce rework. So, you know, with most projects, you want to get stuck in immediately, get some code going, put out a nice, here's a prototype UI, and then you get sort of stuck into it, and you have to then go back and modify the UI, and then you get into the hard bit last, and then you have to modify everything you've done before to be compatible, and the hard bit turned out to be harder than you thought, and it just takes much longer than you thought. The idea of rapid learning cycles is that you spend some time up front learning about things, and you prioritize that, so you close the hardest knowledge gap first, do the hardest bit first, and learn about the bits you need to bring together into your application so that you basically build it and test it once. So yeah, look up Catherine Radika and rapid learning cycles if you're sort of interested in that. But yeah, planning what you're doing, putting some effort in there up front can help you program faster. The next thing to get onto the more like practical LabVIEW tips is to use quick drop. It's much faster if you learn the shortcodes, and it's faster to get to deeply nested VIs than browsing through the palettes. And it sometimes even returns useful VIs that you didn't even know existed. So according to Darren, who wrote this, it's 4 times faster to use. But when I first found it, it's like, how do I learn the shortcuts? You know, some ES and stuff like that. And I thought, oh, I could really do it for a game like VI Invaders. So I thought, how am I going to write one of those? So I started browsing around the forums and discovered that Darren had already beaten me to it. So there's the Falling Shortcuts game, but by the time I found it, there was a few bugs and stuff. So I actually put some effort into fixing it up and making it slightly better. So basically you set it up and hit run, and these VIs will just fall down, and if it's the bottom, the game ends. And I added it so that it will pop up VR there for Open VR reference as a hint halfway down the screen, and you can just practice those codes. So it's quite fun, and it's, yeah, helps you learn those codes so you can use quick drop faster. There's also a whole lot of quick drop shortcuts. This presentation will be available after, along with the videos and stuff, so I don't want you to remember all of these, but it is actually quite a powerful tool to help you program faster. Also too, LabVIEW's got a whole heap of shortcuts. If you search online on Google, you can find this table of LabVIEW shortcuts, which I printed out and put beside my monitor. My favorite is Control U for the diagram and front panel cleanup. Sometimes when I'm writing code, if I know that block diagram cleanup is going to clean it up nicely, I just sort of do a brain dump, get it down, it's a bit messy, hit cleanup, and then just tweak the bits that I don't like, how cleanup works. Also to Control click to swap inputs and connect to plain terminals. I really like that feature that came out a few years ago now. Another thing is, and I've been guilty of this, closing all references, because you know it just feels the right thing to do, but then you're cluttering up your block diagram with unnecessary closes, and you've got to waste time dropping them and then wiring them in. So these references are the ones that you actually have to close. So your ActiveX, .NET hardware ones, your VIs that are explicitly opened or obtained from properties and methods, project items and project references. So if you're using those ones, you have to close them, or else you'll end up memory leaks. But these refs from the Geo object, you don't need to close. So yeah, don't clutter up your diagram and don't waste time closing them. There's a sort of a thing that all VIs need error case structures. And okay, yeah, it ensures your code doesn't execute if there's an incoming error, but for most of the code, 99% of the time, there should hopefully be no incoming error. So is it actually worthwhile spending the time to throw an error case around it? And it is currently the norm in most template VIs as well. So basically, only use it if you need to use it. It gives you less diagram noise. There's stuff that, you know, that if there is an error case, you've got to wire all the wires through it. It's just saving you time if you don't need to have it. And note here, it's in the class template because it's easier to remove than add. So if you use a quick drop shortcut, Control Space, Control R will get rid of your case structure. So if you do need it, perhaps adding a comment to say that, hey, look, I need this error case because, you know, my code is actually going to mess with the error stream and generate its own errors, or I definitely don't need to run this code. It takes a long time because there's an incoming error. So use it appropriately and justify it, I think is the short answer. Yeah. Another one is, you know, people feel obliged to wire every output to terminal, and it does prevent auto error handling dialogues popping up for errors you don't care about. But if you start writing code like this down the bottom here, you're best to just turn it off. I sort of have a love-hate relationship with the automatic error handling. I definitely, if it is enabled and then it starts popping up on me randomly, I just go and disable it in the VI. If you know a function can't reasonably error out, don't wire its error terminal. And it's just saving you time and making the diagram clearer. It's as simple as that, and that's saving you time writing your code. And there is a setting in the LabVIEW options to disable automatic error handling on new VIs. So if you absolutely hate that feature, you can just turn it off. And there's also a VI analyzer test that will detect that in your project, because it might be that when you're running it on your machine, never goes off, then you deploy it into real life, and suddenly you get these dialogues popping up that you didn't expect. Another thing is method VIs need pass-through class wires. So yeah, the train tracks of all these VIs in this class together, yeah, it is visually pleasing. But is it fast and efficient to write? So if the method VI doesn't manipulate the class data, don't make it a pass-through wire. And the dynamic dispatch VIs are happy only having a class input. So then your code becomes a bit more like this. And if I have a problem then with the class data getting modified unexpectedly, looking at this, I know I only need to dive into this one and this one rather than looking at all 6 of them to try and figure out which one's modifying the class data unnecessarily. And then if you're not tied to the train tracks, that same code could be rewritten. And you take advantage of the parallelism of LabVIEW. And I'll also add to it is then, do you also really need all these error wires coming out? If this is unlikely to error. You know, we don't need the error wire coming in here if this one doesn't generate an error, and it's not needed for the sequential nature anymore. So if you can run it in parallel, run it in parallel and ditch the bits you don't need. And one I've been guilty of as well is avoiding global variables at all costs, because you hear that they're evil and bad, but sometimes they're appropriate. So I sort of think of it as horses for courses. Yes, they're very easy to use, but you can also abuse them. And the best way to use globals is to write them in 0 or 1 places. And don't just use a functional global because you think it's better because you're more in control. You're just then wasting time writing a functional global when a real global would actually do the job. So if you're really paranoid, you can use a privately scoped global and to a library and wrap the right operation in a private VI, and therefore you know it's only going to get written in one place and you can read it out. So at my company I inherited some code and it was reading an INI file for an upper limit, closing it, opening it again, reading a lower limit, doing that 40 times 40 darts, times 12 times an hour, times 30-hour test. It was sort of like over 1 million times thrashing this poor INI file. And they say Windows didn't really like that poor INI file getting thrashed, and it slowed down drastically. So, you know, loading those limits into a global once at the start would have been a good example where it would have kept the speed of that code up through all its execution. Another question I'd ask is, should the code already exist? You know, am I running something new and novel, or has someone already bent me to it? So I'd say go and look and see if somebody has already written the code. So at CPE, they've got a touchscreen keyboard that they sell. And you think, yeah, touchscreen keyboard, you know, I just want to, you know, touch this numeric and it should pop up a keyboard, or touch the string and it should pop up a full-blown keyboard. No, that shouldn't be too difficult, should it? But actually, when you sit down and write it, there is actually quite a few fish hooks. And it also uses the event, signaling event node to update the control, which then means you can't use it in your normal code. And yeah. So conceptually simple, but at the end of the day, there was actually quite a lot of work in there, and yeah, I did some work maintaining it as well. So yeah, sometimes if it exists for a reason, and it's usually worth money. And this sort of comes back to don't reinvent the wheel. So there is some hidden gems within LabVIEW, and also searching VIPM to see if somebody else has a library that you may be able to import into your project depending on what you're doing. It's a way of saving time and getting your code out faster. Now, another thing that I did earlier in the year was start playing around with ChatGPT, as I suspect most of you have done. And so I thought, oh, this will be interesting. I'll ask it what it knows about LabVIEW. And it actually gave me back a really good description of LabVIEW. I was quite impressed. It ticked all the boxes. And then I asked it, because LabVIEW is a graphical programming tool, I guess it's really hard for you to help me. And it says, as a language model, it's going to struggle. So, yeah, it turned out to be quite an interesting thread that I ended up with on the LabVIEW forum. Some guy said that he asked ChatGPT and it solved a problem that was totally undocumented, or at least gave him enough clues and pointers in the right direction to solve it for himself. So it's already useful for LabVIEW programmers, so don't just dismiss it out of hand. I admit I've used ChatGPT this year to write some PowerShell script for myself and help me some C# code. So yeah, I was wondering very much how sort of this AI and ChatGPT thing could be integrated into like a graphical programming language. So it turns out that LabVIEW ANZ is working on their own AI called Nigel. And for those who don't know the history, this is the old National Instruments logo, and that is actually Nigel the eagle in there. So here's the presentation from the developer day this year.
A lot about advanced AI and large language models and things like that. Now, how does this apply in the test and measurement space? Now, let me remind you that this is an R&D prototype, and in future, we would only incorporate it in our products after it has undergone rigorous and complete testing. But what could this experience be if we could have AI powered by large language models act as a virtual test engineer? So I have Alejandro back on stage to show me what's the art of the possible. Take it away, Alejandro.
Thank you. Hey, everybody. I'm here again to share what we've been working up in the labs. So this is an AI assistant that can code in LabVIEW, and his name is Nigel. I want to show you today how Nigel can make your life easier. So let's start by asking it what hardware I have connected to this system. So what USB hardware do I have? Great. It's going to mention my simulated NI USB 6003. And so right there, it's generating a table, giving me information on my hardware, the different channels. And I suppose it's also going to give me a pinout, help me connect it. So let's use it to make a measurement. So let's acquire data from AI3. Right. I didn't mention the number of samples or the sample rate. And that's great. The AI is asking me when it doesn't know instead of just guessing. So let's fill this in. Let's say 100 samples at 200 hertz for a measurement just under 1 second. So it looks like it's generating a VI. So this might take a little moment.
So this looks like ChatGPT.
Well, not quite. ChatGPT can write blog posts and emails, but Nigel can control your physical hardware and connect to your apps like LabVIEW, TestStand, and SystemLink. Nigel is tuned for test and measurement for the things that you all care about.
So how does this work?
So we built our AI on top of GPT 4.0 and trained it on NI hardware and software. Then we connected it to the LabVIEW API and taught it about DACMX. This is the first time that I know of that an AI is generating graphical code, and this is only day one. It is apparent that we are only scratching the surface of what this is capable of. It's a really exciting time, Thomas.
So Alejandro, as a software engineer, how do you think such capabilities could change your day-to-day life?
Yes, so this helps me focus where I can add the most value using my expertise. Not deep in documentation or little details. Now I can spend more time on my ideas, solving problems, gathering insights, and doing more of them. Nigel gets me there faster. So it looks like it's done. And so I'm going to send this VI to LabVIEW, and let's take a look. So there is the front panel. We'll come back to it when we run it. Let's go to the block diagram, just verify that it did what it did. Oh, look at that. This is for the guy wearing the "We Want Zoom" shirt out there. We heard you. So let's run this VI and see if it did the right thing. Look at that, a waveform. It worked.
Oh, this is great, Alejandro. You know me, I'm going to be looking for something much more detailed. So is this the only thing that it can do?
No, Thomas. Nigel can do more. So let's just reset this for a second and get started. So let's go back to that DC to DC converter that we were using in the earlier demo. I see here, Thomas, that you actually sent me an email earlier asking me to characterize the power efficiency of that converter at various parameters. So I went ahead and downloaded the spec sheet for that converter board in this PDF, and I'm just going to drop it into the chat. And as I do that, the AI is reading the spec and learning about that DC to DC converter. So the next thing I'm going to want to do is, well, how about if we just take your email as is? Let's just copy and paste it right into the chat window. And immediately, the AI starts responding to your need. First, Nigel is giving you a wiring diagram for the DUT that you asked for with all the hookups to our PXI in the lab. And then, as soon as it's done with the wiring diagram, it's going to start making that VI. Now, this test is a little bit more complex than the last one that we saw. And so it's going to take 3 minutes to generate. And we don't have that time today and during this keynote. So I'm just going to stop it, and let's take a look at one that it generated earlier. So I'm just going to open it up. This is the actual VI that it generates. And as you can see, this VI does a lot more than the last one. It performs 2 DC power acquisitions, and it even does math to calculate the results. Look at how much code this generated in 3 minutes.
Now, this is really impressive because this would allow engineers to spend more of their time on what it matters.
Yes, and I'll admit, for now, this VI is a little messy. But the important part is that it works as is. So let's drop that VI right into the chat. Great. Looks like Nigel has read and understood the VI that I dropped into it. So I've connected the APIs for TestStand and SystemLink into Nigel, which will allow us to deploy and run distributed systems right from the AI. Let's have Nigel deploy it to our lab here on stage. I'm just going to say deploy it to the lab. Great. The AI will respond with a list of systems to deploy to. Let's pick the one that's right here on stage. My buddy Chris is here in the lab to help me run this test.
Welcome, Chris.
All right, so let's select the one right here, Convention Center. The AI will wrap the VI in a TestStand sequence, perform the voltage and current sweeps that, Thomas, you asked for, and then deploy it via test hub to the lab. Great, it's done. Let's have Chris in the lab run our test.
All right, thanks to Test Hub and Nigel, I have everything I need to run my test. Let's give it a try. See it running. And the test passes.
So thanks, Chris. And as you can see, Nigel has done exactly what Thomas asked for.
So remarkable, in less than 5 minutes, we went from spec to test, giving you insights into your duds, which would have normally taken you about half a day. So let's give a big round of applause to Alejandro and Chris. Thank you, guys. Now,
Oh, I think that's where I was cutting off anyway. So, yeah, so I've been programming LabVIEW for 20 years, and I see ChatGPT and AI as a very much fundamental disruptive technology. And earlier in the year, when I sort of started realizing the disruption that ChatGPT could cause, I then got raid for the programming language that I've had, used for 20 years. So I was actually really pleased to find that presentation and that, NI is actually looking and working on Nigel. And yeah, that code looked very AI generated. It obviously didn't go through even a block diagram cleanup, which I think would have made it look quite a bit better. I would hope in the future that block diagram cleanup they can train that as an AI on our code that humans write, so that it, cleans up our diagram in a way that's more humanly acceptable. Because usually when I use the block diagram cleanup, it usually cramps one little part of it, or I still find I have to do a drag here so I'm really hoping that with AI leveraging that I can sort of take LabVIEW a next step and keep LabVIEW development competitive with text-based languages. So for me to wrap up, I'd say keep learning, check out the new features in LabVIEW that make life easier and faster. Go and check out the forums. Feel free to post stuff in there, and attend your LabVIEW user groups, which hopefully will start taking off again now. Hopefully COVID's behind us, and GDevCon. So thank you very much for your time. Yeah.